Welcome, ladies and gentlemen. So what I'd like to do is show you how to write the equation of a polynomial when given complex solutions or complex roots or zeros. But basically, we're going to be writing the polynomial function, so we're going to call these our zeros or our solutions. So basically, if you remember when we were doing rational zeros, all we did was set them equal to x. Then we rewrote them as factors, set them equal to 0. Then we multiplied them together, or set them as factors multiplied to equal 0. And then we FOILed, multiplied, and we got our solution. Well, now we're dealing with complex solutions here. That's what the I, right, or our imaginary roots. Complex imaginary. So the only thing we need to understand is when we have an imaginary number, we have to include both of them. Because again, where does the imaginary number come from? Well, it comes from, again, taking the square root of a negative number. But remember, when we're solving, right, when you're going through factoring or quadratic formula, remember the quadratic formula has plus or minus the square root, right? When you introduce the square root to solve something, you take plus or minus. So when we're solving for complex solutions, when we're solving for solutions, we're not just going to have one complex root. We're always going to have plus or minus. Because remember, you're solving. And when you're solving, you're introducing the square root. When you introduce the square root, you have to include plus or minus. It's also in the quadratic formula. Plus or minus the square root is going to give you your two solutions. So what that tells us is that whenever you see an imaginary solution, the conjugate is also going to exist. Oops, that's not the conjugate. OK, so if I have positive 2i, therefore the conjugate is negative 2i. Now I have my zeros, and I'm going to set them equal to. Now I have my zeros, so I'm going to set them all equal to x. X equals 1, x equals 2i, x equals negative 2i. Then you set them equal to 0, so you solve. So I subtract 1, subtract 1, subtract 2i, subtract 2i, add 2i, add 2i. So therefore, I have x minus 1 equals 0, x minus 2i equals 0, and x plus 2i equals 0. Now I go ahead and multiply these out. And again, you could say, so I could say x minus 1 times x minus 2i times x plus 2i all equal 0. But in reality, they're going to equal our function. So I'm going to kind of get rid of equaling 0. And I'm just going to say we want this to equal f of x, our function. Now, you have a binomial times a binomial times a binomial with complex numbers. So my recommendation here is to always multiply your complex numbers first. Two reasons. One, you get rid of your complex numbers. And two, remember, a number and its conjugate, this creates a difference of two squares. I'm going to multiply the first one out. But for the other ones, I'm just going to simplify it using the difference of two squares. So if you were to use FOIL here, again, remember, when difference of two squares, the middle terms cancel out. So therefore, I have x minus 1, applying distributive property. I'll write this first one out, but I'm not going to do it for the rest of them. X times x is x squared. Negative 2i times x is a negative 2ix. X times positive 2i is a positive 2ix. And negative 2i times positive 2i is a negative 2i squared. Notice my middle terms add to 0. That's what I'm telling you. It's going to happen every single time. So I have x minus 1 times x squared. Now, remember, I squared minus 2 times I squared, which is negative 1. Right? So what's negative 2 times negative 1? Positive 2. So in reality, I have x minus 1 times x squared plus 2. Now I have to use distributive property again, or FOIL. OK, and I'm just going to simplify my answer here. So I'm going to have equals x cubed. Let's see, that's going to be minus x squared plus 2x minus 2. So my function is f of x equals x cubed minus 2x, or x squared plus 2x minus 2. OK? I just didn't write it because I kind of ran out of space. But that's OK. All right, so now let's go and get this one. Now we have a positive and negative, but they're not exactly, they don't have the same value. So we have to use the conjugate for both of them. So that means this now contains a negative I and a positive 3i. So I have 1, 2, 3, 4, 5 roots. It's going to get fun. So I have x equals 0, x equals I, x equals negative I, x equals negative 3i, and x equals positive 3i. Now, set them all equal to 0. So I'd have x equals 0, x minus I equals 0, x plus I equals 0, x plus 3I equals 0, and x minus 3I equals 0. Then write them all as factors times 0. So that's going to be x times x minus I times x plus I times x plus 3I times x minus 3I equals 0. But again, we're multiplying these to get our function f of x, right? So instead of setting this equal to 0, I'm going to set it equal to f of x. Now, you might say, wow, this is a lot of multiplying, right? Way over my head. But remember, when you're multiplying a number by its conjugate, you can easily simplify it down to a difference of two squares. So in reality, I have x times this is going to become x. All you really need to do is multiply the first two terms and the last two terms, because the middle terms cancel out or add to 0. So I get x squared. That's going to be a negative times a negative, so it's going to be plus 1. Right? Negative I times I is going to be a negative I squared. I squared is negative 1. Negative 1 times negative 1 is positive 1. This becomes x squared. This becomes a positive 9. Now I can simply multiply those by using, so really I can multiply these by using the distributive property. So I have x, so times x squared is x to the 4th. That becomes 9x plus x, so it's plus 10x squared, and then plus 9. Then I apply distributive property here, and my final answer is f of x equals x to the 5th plus 10x cubed plus 9x. And there you go. It really wasn't that bad. Now, these two last examples are going to get some students, and they definitely do. So again, if you use the same thinking here, I have 1 plus I. Right? Now remember, when we were talking about our conjugates, if I have 2i, then negative 2i is my conjugate. So if I have 1 plus I, the conjugate is going to be 1 minus I. So again, follow the same steps. X equals 1 plus I, and x equals 1 minus I. Now, as I set them equal to 0, I have to subtract a 1 on both sides, and I have to subtract an I. I have to subtract a 1 on both sides, and I have to add an I. So therefore, I'm left with x minus I minus 1 equals 0. And here I have x minus 1 plus I equals 0. Oops. Let's write this as minus 1 minus I. OK. So now we go ahead and multiply these out. So it's going to look something like this. X minus 1 minus I times x minus 1 plus I equals 0. Now, you can multiply this as kind of like a trinomial times a trinomial, right? 3 terms times 3 terms. Apply distributive property, FOIL, use the box method, whatever you like to. That's perfectly fine. However, what I'm going to show you is a way to simplify that. What we can do is we can group the first 2 terms. You notice the first 2 terms are exactly the same, x minus 1. So now, basically, what I have is a difference of 2 squares. X and x are the same, negative I plus I. Here I have x minus 1 is the same, minus I plus I. So when I multiply these, what I obtain here is x minus 1 squared. And then that's negative I times positive I is, again, we did that where? Over there. So that's going to be plus 1. And again, we're not going to set this equal to 0. Let's set this equal to f of x. So now I just need to multiply out x minus 1. Now that's a perfect square trinomial. X minus 1 squared is x minus 1 times x minus 1, which hopefully you know is a perfect square trinomial, which is x squared minus 2x plus 1 plus 1. Then I add the 1s. So I have my final answer is x squared minus 2x plus 2. Done. OK, so let's go and do this one more time here. Here I have negative 2, and then I have negative 1 minus I. So now when doing a problem like this, again, you have to use your conjugate. So the conjugate, the 1 is still going to be negative. But now my I is going to be positive. OK? And yes, OK. So now, again, let's go and set these. And then I have a negative 2. So I have x. I'm going to set these all equal to 0. So that would be x plus 2 equals 0. Then this would be x plus 1 plus I equals 0. And this would be x plus 1 minus I equals 0. I'm just saving myself that work. So therefore, I have, again, x plus 2 times x plus 1 plus I times x plus 1 minus I. And again, instead of that setting equal to 0, I'm going to set that equal to my function, which I'm trying to find. Now, again, I'm going to go back and do the exact same process I did again. X plus 1s are the same, so I'm going to group them. Now, I can do the first two terms and multiply the last two terms, because it's like a difference in two squares. The middle terms are going to cancel out. Or they're not going to cancel out, but they're going to add to 0. So I'm left with x plus 1 times x plus 1 is x plus 1 squared. I times negative I is going to be a negative I squared. I squared is negative 1, so negative negative 1 is a positive 1. Now, we already did, we did x minus 1. So x plus 1 squared is x plus 1 times x plus 1, which is going to be x squared plus 2x plus 1. So therefore, I have x plus 2 times x squared plus 2x plus 1, and then plus 1. OK? So now I can add the 1 to those two, add those two 1s, and then multiply by x plus 2. However, to do that, again, the best thing I like to do is use the box method. So what I'm doing is I'm multiplying a binomial, x plus 2, by a trinomial, which is x squared plus 2x, and then plus 2, right? Because I added the 1 plus the 1. I just don't want to write another column and show it. So now I just multiply to find the area of each box. X squared times x is x cubed. X squared times 2x is 2x squared. X times 2x is 2x squared. 2 times 2x is 4x. X times 2 is 2x. 2 times 2 is positive 4. So now I combine my like terms here. And what I have is f of x equals x cubed plus 4x squared plus 6x plus 4. So there you go, ladies and gentlemen. That is how you determine the function given complex solutions or complex roots or zeros. Thanks.